The intent of this video is to help you understand how to solve a system with three equations. This video is created as a companion to the Cramer's Rule app, which is available on the App Store. This is a system of equations. In this case, we have three equations, and we have three variables, three unknowns. Turns out if you graphed one of these kinds of equations, say for example the 2x plus 3y plus z equals 3, the graph of such a thing would be a plane, a flat surface. Take a look at the picture here. We've got three planes. I've got the yellow, the light blue, and the dark blue. Now the equations off to the right would describe planes similar to those three. When we're solving a system of equations, what we're looking for is one common point between all three planes. We're looking for one x, y, z triplet that works in all three equations at the same time. Graphically, this means the intersection of those three planes. Okay, in order to do this, we're going to use Cramer's rule. There are other methods to solve these equations. You can use elimination, you can use substitution, for example, but this video covers Cramer's rule. Now in the process, we're going to set up a series of determinants. If you need a reminder on how to calculate determinants, please visit our website at www.reimarapplications.com. So the first determinant we're going to create, we're going to label it D, similar to the case for the 2 by 2 equations. So we'll start with the D determinant. The values that populate that determinant come from the coefficients of the equations above. So that x column, the 1, 1, 2, that first column, comes from the x variables. The 2, 4, 3 in the middle comes from the y, and the negative 1, negative 2, 1 comes from the z. So this is how we create our first determinant, the D determinant. Now we need a dx determinant. And the way we create the dx is simply swap out that x column where the 1, 1, 2 was. We're going to swap it out with the constants, the negative 4, negative 6, and 3. We leave the rest of the determinant untouched. Now we'll create the dy. Now for the dy, I put the 1, 1, 2 back. Okay, we replace the x column, put it back where it was, and this time we'll swap out the y column. Okay, we'll put the constants negative 4, negative 6, 3 in the y column. And finally for the dz determinant, we've got the x's and the y's back in place, and we've swapped out the z column. So we put the constants in the z column. Okay, so now we've got our four determinants. We need to go off and evaluate these four. And we're going to use the values, the results of those determinants, to find our x, our y, and our z. To find the value of x, we're going to take the results of the dx and divide by the results of the d. To find the y variable, we'll take the results of the dy and divide by d. And for the z variable, the results of the dz and divide by d. Now we'll go off and calculate the value for d. In order to calculate the determinant, we're going to expand along the first row. Now we can expand along any row or any column, but we'll work across the first row in this example. So we'll start with the first element, the 1. We cross out the row and the column associated with the 1, and take note of the numbers that are left over. And we'll start by bringing the 1 down, and we'll create a little 2 by 2 with the numbers that were left over. Okay, now we'll move over to the next element in that row. Cross out the row and the column associated with the 2. Again, take note of the numbers that are left over. We'll bring our 2 down and create a little 2 by 2 with the numbers that were left over. And then finally over to the negative 1. Same thing, cross out the row and the column, take note of the numbers that are left over, bring down our negative 1, and create our 2 by 2 with the numbers left over. Okay, Now we need to go off and evaluate these three. Starting with the one on the left, we have 4 times 1 minus 3 times negative 2, and this gives us 10. We'll bring down the 1, multiply those, and we get 10. We'll move over to the one in the middle. We have 1 times 1 minus 2 times negative 2, and this gives us 5. Bring down that multiplying factor, the 2, multiply those two, and we get 10. And finally, the last one. 1 times 3 minus 2 times 4 gives us negative 5. Bring down the negative 1, multiply those two, and we get 5. Okay, now we need to understand how to bring these together. We need that plus minus pattern thing again. Now we worked across the first row, so we need the signs associated with that first row. So that first plus sign comes down with the first item, the 10. The negative comes down with the other 10. And that last plus comes over there with the 5. Now we know how to pull these things together. So we have a plus 10, minus 10, plus 5, and that gives us 5 for a final result. So D is equal to 5. Let's go back where we were. We calculated D. We also need to go off and get dx, dy, and dz. So we've got a fair amount of work ahead of us here. But if we go through and get the values for each of those, this is what we'll end up getting. For dx, you'll get a negative 10. Now we take that dx, divide by the d value that we got a few minutes ago, which was 5. We end up with a result of x equals negative 2. So there's the x part of the solution. Here's the y part. We take the results of our dy, which if you did the work, you'd get a 5 for the result. Divide by the 5 that we got a few minutes ago, and you get a 1. So the y value is 1. And finally, for the z, we take our dz results, which was 20, divide by the 5, and we get 4. So the final solution to this is negative 2, 1, 4. That is the triplet. That's the x, y, z that works in all three equations at the same time. If you were to graph those three, you'd have three planes, and they would intersect at exactly that location, negative 2, 1, 4. Okay, now we got a special case we need to concern ourselves with. Similar to the 2 by 2 situation, when d is equal to 0, we're kind of stuck. We cannot divide by 0. That's undefined. So when d equals 0, Cramer's rule is telling us that we either have no solution or we've got an infinite number of solutions. Now with the 2 by 2 case, there was a relatively easy way to find out what you end up having, whether it be no solution or whether it be infinite number of solutions. With the 3 by 3 case, it's not quite so simple. In fact, the full effort is beyond the scope of this video. But I want to bring up a couple of pictures. Let's see if we can see what's going on. This could be the case with no solutions. If you look at those three and imagine those three planes extending off in all directions, those three planes could be parallel to each other. If they're parallel, they never intersect. Remember, we're looking for an intersection point. So of course, parallel planes would mean no intersection, no solution. Here's another case. Now we've got some planes intersecting each other, but remember, we're looking for one point where all three intersect each other. We don't have that here. We've got two planes that happen to run through that dark blue plane, but they never touch each other in one single location. Here's another case. We've got the three planes. They're intersecting each other in different locations, but again, you cannot find one spot where all three planes intersect each other. Here's an example of an infinite number of solutions. Now we've got the three planes, but look right here in the middle. We've got that line where all three of them intersect each other. So they don't intersect in a single point. They intersect in a line. A line contains an infinite number of points. So this is the case where we have an infinite number of solutions. Another case would be maybe you have three equations that look like they're three separate equations, but they really describe the same three planes. So the three planes are really one and the same. This video was created as a companion to the Cramer's Rule app. It's available on the App Store. This app will help you solve systems of equations in 2 or 3 variables. And it doesn't just give you the answer, it gives you all the details in between. It shows you the matrices that are created during the process of solving, and it gives you the steps in between so you can see exactly how the values are calculated. For additional videos, please visit our website at www.reimarapplications.com.